Hi, this is Dr. S and welcome to video 6 of my series on aromatic chemistry for OCR A-Level Year 13. In this video we're going to look at reactions of benzenes. So we're going to look at how to turn a benzene into different compounds. We're going to look at the reaction to make this and this and these two. Now in my last video we concentrated on the naming of aromatic compounds. So what I'd like to do is have a bit of a recap on that and try and name these 4 compounds that we've just made. Pause the video and have a go at it and come back when you're ready. Okay, thank you. So on the first one here, you should have had this as bromobenzene. On the second one, this is nitrobenzene, methylbenzene, and this one was a tricky one. This is phenylethanone. It's difficult to put this as the branch because of the naming rules that we have. So we use this as the branch, phenylethanone. Over the next few videos, we're going to look at how to make each of those 4 compounds. In the next video, we'll concentrate on bromobenzene, which I think is the first one we should think about. But for the rest of this video, I'd like to think about what type of reaction that is. What actually happens when a benzene turns into a bromobenzene? So let's think about the type of reactions we've seen at year 12. We've seen different mechanisms. For example, we had the mechanism of turning an alkene, reacting that with bromine and turning it into a dibromoalkane. And we should remember that this was electrophilic addition. It's electrophilic because the bromine is acting as an electrophile. It is attracted to the electron density of the double bond. And it's an addition because 2 things have been added together to make 1 product. Another mechanism you saw in year 12 would be when we have a haloalkane and we react it with hydroxide ions to form the alcohol and kick out a bromide ion. In this case, we have a delta negative bromine and a delta positive carbon, which is the bit that is attacked in the first step of the mechanism by the lone pair of the hydroxide. The hydroxide is attracted to the delta positive carbon, so that is a nucleophile. So this is nucleophilic. And if you look at what's happening, 2 reactants are coming together to make 2 products. The OH has taken the place of the Br, so this is substitution. So what I'd like to think of before my next video is what type of reaction is the reaction of benzene to make bromobenzene. I'll show you the reaction here. It's benzene plus bromine makes bromobenzene, but you might see that one of the bromines is missing, one of the bromine atoms. It actually makes an HBr. Remember that the benzene here has 6 hydrogens on, 1 on each carbon. Well, the hydrogen on that carbon has now been replaced. So just have a minute to pause and think, what type of reaction mechanism do you think this reaction is? Okay, well in this case you've got 2 reactants coming in, 2 products coming out, so it's substitution. Think about what this bromine is here. Although it's not reactive straight away, in the next video we'll look at exactly how it reacts. It's attracted to the electron density of the benzene ring. So it's an electrophile. So this is electrophilic substitution. The next video will concentrate on the exact mechanism of electrophilic substitution. Before you go to video 7, can you please try and flick back to year 12 and look at your electrophilic addition mechanisms. I'm going to see whether you can remember how to do a perfect mechanism. So what I'd like to do before the next video is the reaction that I said on the previous sheet. But2e plus bromine makes 2,3-dibromobutane. Using dipoles and curly arrows, can you try and draw a perfect mechanism for that reaction before my next video? Have a go at that, and I'll see you then.